Dear students, let us do some more problems of center of mass. A uniform wire is bent into the form of a rectangle with length L and width W. If the two of the sides coincide with x and y axis, what are the coordinates of center of mass? Suppose this is x and y axis. A uniform wire is bent in the form of a rectangle. Like this it is bent. Its length is L, its width is W. If the two of the sides coincide with x and y axis, what are the coordinates of center of mass? See, this is the midpoint and this will be it's a center of mass. So this center of mass is represented by xc, yc. xc, yc is equal. So xc is its x coordinate. See, half of this length L by 2. Y coordinate half of the W. That's all. Now let us consider this. Choose a large bond book. If it is placed on the table, locate its center of mass. Large bond book, it can be taken as a parallelopipe like this. Suppose this is table. On this, a large bond book is like this. It's like this. So the midpoint will be the center of mass, COM. COM, center of mass. This is table surface. Second one, if it is made to stand vertically on the table, will the center of mass remain same? The same bond book is kept vertically. It is kept like this. It is kept like this. Now the center of mass will be somewhere here. Now we can easily see that the height of the center of mass from the table surface has increased here. But as far as the bound book is considered, the center of mass will be always at its center point. As far as the book is concerned, center of mass is not changing. Only here the coordinates are changing. If you are considering height of the center of mass from table surface, then the height is changing. But as far as this book is concerned, its center of mass is same. If it is placed on the table and open it such that half the number of papers are to one side and half to the other, where will the center of mass now be approximately? So this book is this time half pages to one side, half pages to another side. Now obviously the center of mass will be here. If 3 by 4 of the papers on to one side, to which side the center of mass will shift? So here 3 by 4 means, suppose 3 by 4 to left side, 3 by 4 to left side, and 1 by 4 to another side. Suppose the pages are like this. Now the center of mass cannot be in the middle, because this side more mass, this side 3 by 4, this side 1 by 4. So it will be somewhere here. Somewhere here. It means what? Here, see, the center of mass depends upon how the mass is distributed. On distribution of mass, its location depends. Now, let us consider some problems from this. Here, let us consider the 9th problem. Let us consider the 9th problem here. If the center of mass of 3 particles of masses, see 3 particles, m1 1 kg, m2 2 kg, m3 3 kg, at the center of mass of the 3 particles, center of mass xc, yc of the 3 particles is at, then where should a 4th particle of mass? See the second part, let us see afterwards. First, 3 particles mass is given and center of mass is given. Now it's the coordinates of m1 mass will be x1 y1, and m2 mass x2 y2, its coordinates, and m3 mass is located at x3 y3. So center of mass is defined as xc is equal to m2 x2 plus m3 x3 by m1 plus m2 plus m3. Similarly, yc is equal to by m1 plus m2 plus m3. Similarly, see here 3 coordinates are there. So the 3 particles are located in space. So here zc also comes, and here x1 y1 z1, x2 y2 z2, x3 y3 z3. Now zc is equal to m1 z1, m2 z2, m3 z3 by but here xc, yc and zc are having same values. Therefore, if we consider just one, that is enough. Let us consider this one now. xc value is 2. m1 x1, m2 x2 plus m3 x3 divided by m1 plus m2 plus m3, 1 plus 2 plus 3. Or 5 plus 1, 6, 6 into 2, 12. So we got one equation. Now let us go to the next part. Where should a fourth particle of mass 4 kg, fourth particle, 4 kg, and its coordinates are x4, y4, z4. This is located at this place. Be placed so that the combined center of mass may be at 0, 0, 0. So now the 0, 0, 0 is center of mass of 4 particles. So center of mass of 4 particles. See, first let us find the xc. m3x3 plus m4x4 by m1 plus m2 plus m3 plus m4. xc, see, that is 0, and from here to here it is 12. So from here to here it is 12. So 12 plus m4 is 4 kg. This value is 12, therefore in place of this we substitute 12. Remaining is m4 4 kg, x4 by m1 plus 2 plus 3 plus 4. Or cross multiplying 4x4 plus 12, 7 plus 2, 9 plus 10, 10 into 0 is 0. Or x4 is equal to this minus 12 by 4 minus 3. See, yc also 2, zc also 2, therefore y4 also we get minus 3, and for z4 also we get minus 3. x4, y4, z4. So here, what is asked here? Where should a fourth particle of mass 4 kg be placed? To get this new xc, yc, zc, means we got the answer. The fourth particle must be placed at minus 3, minus 3, and minus 3. At this position it must be placed. Now let us do the 12th problem. A uniform disk of diameter r by 2 is put over another uniform disk of radius r of same thickness and density. The peripheries of the two disks touch each other. Locate the center of mass of the system. See here, let us draw x and y axis. This is a disk, larger disk, having radius capital R. It is having a radius capital R. And another smaller disk of radius, diameter r by 2 means radius r by 4. placed over it. It is placed here. This is r by 2. See, diameter r by 2. R by 2 diameter on this. The peripheries of the two discs touch each other here. Now we have to find. So smaller disk is placed over larger disks. Now we have to find center of mass of the combined form. So let M1 be mass of larger disk and its center point. So this is M1. This is having mass M1 and this is its center point. Let us draw the diagram. We are doing 12th problem. This is x-axis, this is y-axis, this is origin, and its radius is r. Its radius is r. Now a uniform disk of diameter r by 2 is put over. See, from here to here r, and from here to here r by 2. This is r by 2. Here to here r by 2. So diameter like this. So its diameter is r by 2. Midpoint is here. Suppose larger disk's midpoint is C1 and shorter disk's diameter center point is C2. Okay. Now M1. Twelfth one. Now M1 mass of larger disk C1 is equal to x1 y1 is equal to, here it is nothing but origin is equal to center of larger disk. Now M2 is, its mass is M1, its mass is M2. mass of shorter disk C2 x2 y2. See here its coordinates from here to here means, see from here to here r by 2, and from here to here half of r by 2. R by 2 plus here to here r by 2, here to here r by 4, comma y2. It is on x-axis, therefore its y coordinate is 0. See, this is center of shorter disk. So here this can be again written as C 2 3r by 4 comma 0. So this is C2. Now usually we make use of formula like this. See, xc is equal to m1 x1 plus m2 x2 by m1 plus m2. Similarly, yc is equal to m1 y1 plus m2 y2 by m1 plus m2. But in this problem, masses are not given. So now let us use the concept of mass per unit area. Sigma is equal to m by a, or m is equal to sigma a. Then automatically what happens? m1 is equal to sigma a1, m2 is equal to sigma a2. So substituting these values here, substituting these values in this, x is equal to m1 means m2 means, see here, x1 sigma a1 x1 plus sigma sigma cancel. Just like this for yc also we get a2. So now x1 x2 y1 y2 available. Now we want a1 a2. See, a1 is area of larger disk. So it is a circle, therefore pi r square. Pi, its radius is r. Now a2 area of smaller disk. Its radius is r by 4. Diameter r by 2 means radius r by 4. Now substituting the values, Now let us substitute the values. Xc is equal to Xc is equal to A1 x1. A1 is pi r square. X1. X1 is 0 plus A2 X2 also X2 is here 3r by 4 3r by 4 by A1 plus A2. So this becomes 0. So here 16 plus 1 17 or pi r square by 16. Now we have to find Yc. See, to find Yc the formula is this one, A1 Y1 plus A2 Y2 by A1 plus A2. But Y1 Y2 here, Y1 is 0 and Y2 also 0. So this 0 means entire Yc also becomes 0. So center of mass becomes 3r by 68 by 0. So this is the answer. Now let us consider another problem. A disk of radius r is cut out from a larger disk of radius 2r in such a way that the edge of the hole touches the edge of the disk. Locate the center of mass of the remaining portion. This is a disk of larger radius. Its radius is 2r. A disk of radius r is cut out. See, here to here or here to here or. So a disk of radius r. So this disk is having radius r is cut out. This is larger, this is smaller, and this is being removed. See, larger disk center is C1 smaller disk center is C2. So A1, area of larger disk. So radius is 2r, therefore pi now its center is taken as origin. X1 y1 is equal to 0 0. A2 is area of smaller disk. Its radius is r. Its center is, say its center is x2 y2. So center x2 is from at r distance from origin, or y2 means it is on x-axis, therefore its y coordinate is 0. Now to find center of mass, xc is equal to a1 x1 plus a2 x2 by a1 plus a2. But here this part is being removed. Here you see 13 is cut out. Therefore we put minus here. Here also minus. Minus. Since A2 is cut out, minus sign. Xc is equal to 4 pi r square, x1 0, a2 pi r square, x2 r by a1 minus a2 pi r square. This is 0. Pi r square into r by 3 pi r square. Pi r square, pi r square, r by 3, here minus sign, here minus sign. Now yc is equal to a1 y1 minus a2 y2 by a1 minus a2 is equal to here a1 4 pi r square, y1 is 0 and a2 pi r square, y2 also 0, so 0. So in this way we got the center of mass xc yc is equal to minus r by 3 0. So this is the center of mass of remaining part. Now let us do the 14th problem. Let us choose this circle here and the square here. From here to here diameter, this also d value, both are having same. Now look at the center of mass of this combination. Suppose this is C1, this is C2, C area. See area, this is a circle, therefore pi, its radius, diameter is d, radius is half of d. Pi d square by 4. Now its area, now it's C1, x1, y1, just origin 0, 0. Now A2, its area, it is a square, so square area is side into side, d square. So center point's coordinates are here to here d by 2, here to here d by 2, so d. So x2, y2 is equal to d by, it is on x-axis, therefore its y coordinate is 0, d. So now xc is equal to a1 x1 plus a2 x2 by a1 plus a2. That is equal to here a1 pi d square by 4 into 0 plus a2 d square into d by pi d square by 4 plus a2 d square. So x is equal, this becomes 0, d cube. So d square into d by here 4. See here, d square if taken as common, pi by 4 plus 1, d square taken common. So d square gets cancelled. Now d by 4 plus pi by 4. 4 comes up, 4d by 4 plus pi. So this is the xc value. Now yc, see here, y1 and y2 0, therefore yc also will be 0. So xc yc is equal to 4d by 4 plus pi comma 0. So this is the center of mass of this combination. Now let us do 16th problem. Two blocks of masses 10 kg and 30 kg. See here, this is y-axis, this is x-axis. Suppose this is 10 kg. See x-axis, this is y-axis. Here m1 is equal to 10 kg and another is 30 kg. Suppose 30 kg is here, M2 30 kg placed here. Here it is C1 is equal to x1 y1. So let us take, because these two blocks are on x-axis only, so y coordinates will be 0. So let us consider only x coordinates. Here this is C2, C2 is equal to x2 here, and C1 is equal to x1 is equal to 0 because this is origin. Now C2 is equal to x2, and now it's a center of mass. Center of mass xc is equal to m1 x1 plus m2 x2 by m1 plus m2. m1 is 10 kg, x1 is 0, plus m2 is 30 kg, x2 is x2 by m1 plus m2, 10 plus 30, so that is equal to 30 x2 by 40, or 3 by 4 x2, 3 by 4 x2. Now afterwards, see, the first mass is moved on the axis by a distance of 2 centimeters. Suppose this is moved by 2 centimeters. Suppose this is moved from here to here by 2 centimeters. It's moved by 2 centimeters. It means now C1 dash or x1 dash, the new coordinate for the first block will be 2 centimeters. So now to have the xc value at the same place, by what distance this must be moved? So this must be moved this side, this must be moved this side. See, this is C2 dash and x2 dash. Now C2 dash is equal to x2 dash is equal to how much, that we don't know. But after moving the center of mass will be now new center of mass. New center of mass is equal to m1 x1 dash plus m2 x2 dash by m1 plus m2. So 10 x1 dash is 2 plus 30 x2 dash by m1 plus m2, 10 plus 30. So this is xc dash, but given both are same, unchanged, position of center of mass is unchanged. Given 1 is equal to 2, that is xc dash is equal to xc. So xc dash is 20 plus 30 x2 dash by 40 is equal to, and xc is 30 x2 by 40. 40 gets cancelled. Now let us move this to right hand side. So 30 x2 minus 30 x2 dash is equal to 20, or taking 30 common, x2 minus x2 dash 20, and x2 minus x2 dash is equal to 20 by 30, that is 2 by 3. x2 minus x2 dash. So here in this diagram, x2 was here and x2 dash is now here, new position, x2 minus x2 dash, so 2 by 3. So by 2 by 3 centimeter, this must be moved towards origin. So therefore larger block must be moved by 2 by 3 centimeter towards origin.